Discussing about the root mean square value of the alternating EMF or voltage, we define the RMS value of alternating EMF or the voltage as the voltage that will produce the same amount of heat in a given circuit in a particular time as is produced by the AC in that amount of time. As already discussed, in getting the RMS value, we integrate from 0 to T, that is for a full cycle, because the heat produced doesn't depend upon the negative and positive cycle. Heat is produced in both the cycle, whether the direction of current is from left to right or the direction of current is from right to left. Heat is produced in every direction. Now, we have that if E is equal to the instantaneous value of the EMF, that is equal to E0 sine of omega T. Now, if dH is the small amount of heat produced for a small amount of time, dt, for which we can take that AC as constant, dH is equal to I square R dt. Now, this dH is equal to, taking I equal to E divided by R, we have E divided by R whole square into R dt. So we have dH is equal to, taking E is equal to E0 sine square omega t, that is E0 square sine square omega t divided by R square into R dt. One R gets cancelled out, so we have got dH is equal to E0 square divided by R sine square omega t dt. Now, to get the total amount of heat that is produced between the 0 to T, that is for a full cycle, we have to integrate this from 0 to T. Integrating dH from 0 to T, we have integral of 0 to T E0 square divided by R sine square omega t dt. Now we have H is equal to, taking E0 square divided by R out of the integral sign as it is constant, integral of 0 to T. Now this sine square omega t, as per the formula, is 1 minus cos of twice omega t divided by 2, and taking this integral dt. Taking 2 out, H comes out to be E0 square divided by 2R integral of 0 to T dt minus integral of cos of twice omega t dt from 0 to T, as we have already discussed in the current. Now, H comes out to be E0 square divided by 2R, taking this integration first, that comes out to be T, taking the limits, that is T minus 0, minus. The integration of cos 2 omega t is sine twice omega t, internal integration is 1 by 2 omega, the limits are 0 to T. So we have H is equal to E0 square divided by 2R into T minus, taking 1 by 2 omega out as it is constant, giving the limits, we have the upper limit sine of twice into 2 pi by T into T minus sine of, giving the lower limit sine of 0. Here H is equal to E0 square divided by 2R into T minus 1 by twice omega sine of 4 pi minus 0, as sine 0 is equal to 0. We also know that sine of n pi is equal to 0, so this term becomes equal to 0. So we are left with H is equal to E0 square divided by twice R into T. This is the heat produced by the AC for a full cycle. Now, taking if ERMS is the value of root mean square voltage or the EMF, so heat produced by ERMS is equal to ERMS whole square divided by R into T. Now, as the heat produced is the same, we have E0 square into T divided by 2R is equal to ERMS whole square divided by R into T. T and T cancels out, R and R cancels out. We are left with ERMS whole square is equal to E0 square divided by 2. Now, ERMS is equal to E0 divided by root 2. So, the value of ERMS is 1 by root 2 times the peak value of the AC or amplitude of the AC voltage or EMF. Now, taking magnitude wise, we have ERMS is equal to E0 divided by 1.414, that is equal to 0.707 E0. So, the ERMS value or RMS value of the alternating voltage or EMF is equal to 0.707 times the peak value, that is the amplitude of the AC, that is E0. Now, also taking percentage wise, we have ERMS is equal to 70.7% of the peak value or the amplitude of the AC voltage or EMF. So, remember one thing, the mean or average values are defined for a half cycle, and the RMS values or the root mean square values or the effective values are defined for a full cycle.